So my name is Garrett Smith. I'm a programmer at CloudBees, and I'm going to be talking about building an application platform. But first, a little bit about me. Probably, you may have heard of CloudBees. You almost certainly have not heard of me. CloudBees is a Java platform service called PaaS, Platform as a Service provider. But you may have watched a video that I've made. These are fairly somewhat well-known. There's MongoDB as web scale, and then there's Node.js as badass rockstar tech, and there's a bunch of other ones. So if you're even remotely interested in listening to two video bears bantering back and forth about techno stuff and want to be somewhat amused, it does take like 5 minutes per video, so I apologize for that. There's a link afterwards so you can find all these good things. So if anyone's seen this, you probably have a feel for who I might be as a person. So you'll know that I'm probably a smart ass. I have anger issues, and I'm disturbed. How many people have seen this? Okay. So you know that this is true. You've seen this and understand. So if I get into any of that stuff, you won't be surprised, right? If I start to rant and go crazy and melt down and shout, you'll be like, yeah, that's that guy. All right. So with that, we're going to go to the cloud. So I don't know if anyone from the States, I don't think that Microsoft ran this ad campaign outside of the States, but last year, this is sort of, as you know, I'm part of a cloud company, a cloud startup. They had this completely infuriatingly absurd campaign called, To the Cloud. And it was like, I've been diagnosed with cancer and I'm going to die, to the cloud. And I broke up with my girlfriend, to the cloud. It was just like the cloud is going to solve every possible emotional problem that you could ever run. And here I am trying to build software for the cloud and trying to help people use the cloud and be specific. And these guys are this is Microsoft. So I want to be specific about what we're talking about. When we're talking about application platform or cloud, I don't want to use a really fuzzy definition for an already abstract concept. So let's be very specific about what the cloud is. So for me, my personal bent on this is kind of a fancy definition. It's disintermediated services delivered over a network. So disintermediation is very simple. It's removing the middleman. Now, I don't know if this guy exists outside the US, but this is the guy who you're in the bathroom and you're just like, I'm here for a very specific reason and that's it. And he wants to hand you the towel and you're just like, I don't want you to hand me the towel, I just want to go use the towel. That's a middleman. That's somebody who wants to intermediate, provide some sort of service for you. In this particular case, I do not want that. I don't want disintermediated services. So this is that delivered over the network. Most people intuitively know what the cloud is, but really what it is cutting out this middleman. The middleman effort is about doing things that aren't really productive. You want to accomplish something, and there's something in between you and that goal, right? So this is fairly basic. Everyone's like, yes, we get it. Remove the middleman. But too often we are blocked by all sorts of crazy complexity. So processes and workflow and approval process, budgeting process, procurement process. You have workflows. And you go from like an idea that could be very intuitive and straightforward and something you want to experiment with and learn from to this big, long, extended process. All the stakes are raised because of the time and money and energy and life force is so huge because of this middleman dynamic. You can't iterate. You can't just say, hey, I want to try something here. You've got this, this stretch of a program just to go and deploy a server and try some software and try this particular thing and that type of thing. So the cloud has a lot to do with removing that so you can just experiment. So I think it's a big concept. It's really, the cloud is kind of a bit of a marketing thing. Just think of removing the middleman, removing friction, removing blockers, making it easier and faster for folks to get things done that they want to get done. It's very simple, but what's wonderful about cloud services is you have this huge lever to do that. So we're going to talk a little bit about what exactly we're talking about from an application standpoint. From an application standpoint, let me skip here. We're talking very simply about a developer who wants to deploy an application to an application environment. That's when I say application platform, that's what I'm talking about. A disintermediation of this process. So make it as easy as possible for Joe developer, me, you, whoever else, Jane developer, deploy application environment. The sub-functions or the implementation details are hidden. Or they may not be completely hidden, but there's an abstraction above that. Now this technically is a middleman, if you catch my logical flaw here. But really the point is I want to get my application deployed. I don't want to know necessarily about servers, network topology, application architecture, databases, et cetera. I just want to code, push, experiment, iterate, improve, and get through this process. No middlemen. It's all API-based. It's all streamlined, and that's when I talk about application platform, that's what I'm talking about. So, of course, this talk is about how to do that, lessons learned. So what I'm going to walk through is, some of the essence, the most important things that you need to know. You may not actually be building one of these things, but you might be building something like this. So disintermediation of services, that is removing the middleman, is something that we can all do. This is not necessarily limited to cloud vendors. So I'm going to give you the absolute law, like the how to write this down, because it's reflective of so much wisdom and experience. The first thing, when you have a big idea and you want to go build some huge thing, you need a big plan. You need to sculpt and craft every detail to fulfill that plan, to fulfill that vision before you start. So you make a model and you demo the model and you solve the engineering problems and you build foundations, and this is what you lay out first, right? So the next thing is to get a message bus. So you can't possibly have any kind of cloud service or any kind of disintermediation of service without some way of communicating with that. You have to have a message bus. It's absolutely essential. So that's the first thing that you need. The second thing, after the plan and after the message bus, is a distributed NoSQL database. SQL is like 1980s, 1990s. We have, like, 2000s, we're already 2010. It's distributed, it's globally distributed. You can't have like one server. You have to have like 10, and they need to be in different data centers. They need to be replicating and right behind and right ahead. Fancy stuff. That's number two. Number three, of course, how are you possibly going to do this without a rules engine? How do you build anything without a centralized brain that says, given this input, do that? I'm going to control every aspect of this set of services. How do you possibly implement that without a rules engine? I have no idea. All right, now with that, I'm going to pause and let you soak in the smart-assness of my disturbed mind, because I'm putting you on, right? You guys should all be like, wait a second, something's wrong here. This smells terrible, terrible, terrible. And if you don't, if you're like, oh, yeah, message bus, definitely need that, rules engine, how could you possibly, yeah, totally. Distributed database, absolutely, has to be distributed NoSQL. If you're saying that, then this is a great talk for you, because I'm going to just obliterate all this stuff. This is all, can I swear? Can I melt down here? So this is wrong. This is terrible thinking. And honestly, it was my thinking going into this. And frankly, it's a temptation of mine to think like this. Anytime you have a big problem, anytime you have some vision, you need some big armor, some big vehicle to tackle that. The problem with that is it's kind of a fallacy. It's a mistake. It's taking an engineering solution for one set of problems and applying it to your particular problem. Right, so in this case, we have an example of, let's say this is a message bus, and I just need some trivial communication. We have this huge infrastructure, this huge vehicle that we think we need because this is what people use, and this is our problem. We spend a lot of time and energy procuring this, either through license fees or adoption of new technology, and then we have this problem, and we find that it doesn't work very well because there's this mismatch. Right? Or let's say you solve the problem absolutely. You completely nail the problem, but it's a problem. It's a solution to a problem that's an invalid problem. It's the wrong problem. So this is a picture of a bridge. There's a famous bridge in Alaska, in the United States, that was built. It goes to an island that has no one living there, and so it's a beautifully engineered bridge. It was the right solution, right? They solved it definitively, but it's absolutely the wrong problem. And infuriatingly, well, let's just say this: it's an entertaining problem. In the United States, we like to pay our politicians to entertain us, and this was terribly entertaining. I mean, this was on the news for months and months and months, and people lost their office. But my goodness, it was worth every penny to spend to entertain us for that. But that's a beautiful solution to a problem that is not a valid problem. What's that? Yes, that's what it translates into. So I like to go back to, so there's the 80-20 rule, there's all these clever rules. This is a really, really good rule. This is the 1%, 99%. So this, of course, is Thomas Edison, and he said, one of his great quotes is this: that genius is 1% inspiration, 99% what? It rhymes with inspiration. Perspiration, okay, everyone, good. 1% inspiration, 99% perspiration. That is, we don't think, we act. This is what he's saying. So this is a guy who is clearly not thinking the way we would think on a normal day, thinking differently. But I didn't see this. I did not take this picture. I scoured the internet because this is probably the most entertaining photo I could find of somebody not thinking terribly clearly but acting. This individual is going to be capable of a lot of surprising behavior, surprisingly capable behavior, movement, speech, interaction, but there's almost no real thought going into it all. So back to this. 1% sort of vision, planning, ideas, 99% work. There's a difference between what goes on in your brain and what goes on in the laws of physics. Now, a lot of people I know don't like to see themselves professionally as this. I call this drunken stumble. So drunken stumble is the ability to walk when you really can't walk. Now, I've actually had this problem a few times. So occasionally, I will sleep past my stop on a train, and then I get off, I'm like, okay, how long do I have to walk? And sometimes I can walk very easily, and sometimes I cannot walk very easily. And this one particular time, it was in the dead of winter. So the stakes were very high, because if your blood alcohol is a little high and it's cold out, you don't want to go to sleep in the snow, even though you really, really want to. So I had to walk literally 3 miles, not able to walk, but using a methodology like this called drunk, where you basically just lean and then let gravity kind of take you forward. And I was shocked at how effective that was when I couldn't actually get someplace, but then I actually got someplace just by obeying the laws of physics. But friends of mine, they say, Garrett, I kind of understand what you're saying here. It's an interesting philosophy to associate a programming methodology with drunken stumble. But I don't really want to see myself like that. I kind of want to see myself like this. I want to see myself as an Olympiad whose beautiful gestures as a result of practicing something over and over and over again. Fine. If you want to be an Olympiad, that's fine. Okay. The difference is that the Olympiad gets to do the same problem over and over and over and over and over until it's perfect. There's no thought. It's all muscle memory. Right? This is really what we do. We are experimental. We're creative. We do new things all the time. There's really nothing to repeat in what we do. It's always different. So now, I know you're saying truly bizarre and truly disturbed, and I'm not sure this is going to work out for me as a talk. Let me continue. Just give me a chance. I'm going to resolve this conflict in your mind, hopefully. So what we're going to do is we're going to go through an exercise of drunken stumble. We're going to basically build out platform services using this sort of, I'm not going to think at all. I'm just going to do the most obvious thing. So I want to lay out some foundational principles so that we have the rules to conduct this exercise. So rule number 1, treat problem definition as a guess. There's a lot of people who skip problem definition altogether and they say, here's the solution. You will hear words like, okay, this is what we want to do. This is what we need to do. Let's do this. Okay, we're going to do this, right? What they should be saying is, hey, this is kind of what I'm thinking right now. Or, what do you think about this? Or, I'm going to throw this against the wall and see if it sticks. Different types of language, different way of approaching. There's an inherent skepticism of your ability to understand what it is you're trying to solve. Right? Remember that bridge to nowhere? How many projects, and with great intention and brilliant people, end up building that bridge to nowhere? If they were skeptical of the problem to begin with, they might have questioned it and said, do we really want to build a bridge to nowhere? This island where no one lives? This is like a $2 billion investment. What? Does this make any sense? Different problem, I understand. It's shift the definition. But rule number 1 in this exercise is anything we do, we're going to be skeptical of it. We're not going to be overly confident. Number 2 is only ever work on the next obvious step. Now, this is the inherent rule of drunken stumble, right? The only way that you're going to get home in the dead of winter when you actually can't walk is to just worry about the next step. You allow the laws of physics. You let physics prevail, you allow your instinct to take over. You don't have a higher brain function by definition, right? It's drunken stumble. But somehow you make it home. So this is really going to be the vehicle that's going to propel our system forward. So we're only ever going to work on the next obvious step. Number 3 is we're going to minimize size, maximize autonomy. Now this isn't really a rule. This is a very challenging and actually sort of deep thing that I have at stratospheric height, abstraction-wise. To minimize size and maximize autonomy is easier said than done. It's very challenging in some cases, but it's a guideline. So if we have to say, is one option better than the other option, this is going to be one of our leading thought provokers. We're going to think about this. We're going to think about how big is this and how autonomous is. Or the inverse would be how interdependent are we making our system. So this is not so much a strict rule as it is a high-level guideline. All right, so we clear on the 3 rules. Those, we can't break these. And then this last one is kind of a guideline. Okay. So what you'll notice, this is going to be a prediction. I'm going to call the shot here. This is what's going to happen if you do these 3 things. Things are going to work better. You can evolve incrementally by adding things and replacing things from your system. This is something that I've learned in the tsetse-fly experimentation of Erlang development, that you don't try to solve hard problems of corrupt state. You say, punt the state, throw the state away, restart to a known, fresh, clean state. It's like rebooting a computer, rebooting an access point, any of the problems you have with anything, a car even. A car, I turn it off and turn it on and something fixed. It's remarkable what you can fix by rebooting something. But small and independent allows you to do that. So number 2 will be one of our benefits. And then failures are less severe and easier to fix. Smaller independent things makes any one failure less severe. Right? It does. Our cells, we're losing cells all the time. They're dying, but we exist all the time. I don't know, it's like 5% of our bodies lost. I don't know, some crazy statistic of our bodies lost through just normal attrition of cells. But somehow we still exist as an organism and evolve. So our systems will be, the systematic failures will be small or less, and they'll be easier to fix because something that's small is easier to understand than something that's complicated, generally, hopefully. In this universe, I've observed that. All right, so we're going to go through an exercise. I have a little bit of all this background stuff. Let me just rush through this because I think the exercise will be interesting. So this is stuff I like to use. Now, I'm not endorsing anything. I'm not saying that, hey, to go build something, go do this. I want to just hit on a few of these things to show you, at least in my brain, why, on its merit, one of these is good. So Arch Linux I like because it's a rolling distribution, small and incremental. The Debians and Fedoras, Ubuntus are fixed distributions. Now they're constantly updating, but every once in a while you have this big old upgrade. And if you have any of those distributions, you know that big upgrade can be very risky. Now that said, Arch Linux is very risky as well. There's trade-offs, but I prefer the trade-off combo that Arch Linux. This is just my thinking. Don't rush out and use Arch Linux, but it illustrates how one might pick an operating system that complies with these principles. SSH, SCP, rsync. These are all sort of shell or IO-based interfaces that are incredibly powerful. You can talk to computers all over the world using these three protocols, basically based on SSH. You could use RSH, no one does, but it's a straightforward, direct protocol. You don't have to get real fancy all the time with the way you communicate with things. Bash, no middleman. There's no middleman there. It's like you and the operating system are one. Right? It's this nice, no impedance mismatch there. You type ls or grep or awk, or and you can write all that stuff in Bash. It's a beautiful language. It's not a beautiful language. In that sense, it's a beautiful language. Of course, Erlang, of course. Erlang is the epitome of these principles. In fact, I'm almost ashamed to admit my fanboydom here, but it has been so informative just because as I use this language, the authors really understood this dynamic. Operating system designers understand this dynamic, these things I'm talking about. So this has really influenced my thinking and has caused me to try things in a certain way that I'm like, wow, that really works well outside of Erlang. Python, very straightforward language, not a lot of ceremony, lets you do things very directly. Use 0MQ for messaging, very straightforward, very simple protocols, very flexible. From a messaging standpoint, this is the embodiment of what I'm talking about. SQLite, very straightforward relational database. MySQL, lots of people have had bad experiences with MySQL, so have I, but I like it. I like it because it's sort of straightforward and direct, and it's useful, and it does the job. And of course, Memcache is one of the most straightforward and elegant tools that you can find. So the reason you can see I like these is the straightforwardness. Yeah. I should have probably put C up there now. Yeah. I'm sorry. There's probably a few more things that I left out, but this is of the nature of things that. Now, to be fair to the things that I don't like, the evil side of me, I want to harsh on some. Now, of course, I'm not harsh. All of these are fantastic technologies in one way or another, and all of these have weaknesses in one way or the other. There's always trade-offs. There's hardly ever, there's no moral framework that I'm using here. There's just sort of the way things have been designed and the approach tend to be more consistent with what I'm saying and less consistent. Is that coined enough? So I'm not going to be like ridiculed. Like, guys, bashing AMQP. AMQP is a very complex protocol. It does a lot of things that you might not need. So I tend to stay away from it. Now, it's not novel. It's novel databases. Databases that are solving a very specific problem that I probably don't have. The forklift image. Right? I'm long since past the kind of, the cool kid phase where like the latest, ring topology distributed database is released, and I'm going to go out and figure out how to install it into my environment. I'm skeptical of it. I'm going to wait until somebody else, I'm going to wait until it's obviously the right thing for me to use. Chef and Puppet, to me, we use these. I know people who love them. I don't love them. They seem like the very heart of middlemen, of middleware, of intermediation. I like Bash. I like just to run Bash scripts. It's straightforward. Debian Fedora, as I said, fixed distributions. Of course, these are great. These are all great things. Nagios, complex, complexity kind of overload for me. And probably goes without saying, proprietary software. You need to have a really, really good reason today, I think, to use proprietary software for all of the things that I've been talking about. And then when you go about doing anything today, I think it's a logical starting point to say, is somebody else doing something out there that I can just use? Cloud? Can I go to the cloud? Can I make my life better by using Amazon Web Services? Yeah, you probably can. And we use them extensively, and I have almost exclusively good things to say. Pingdom is a monitor. You can monitor different endpoints, and they'll notify you if things go down. Papertrail is a consolidated logging. New Relic is analytics for Ruby and Java. They may have other runtimes I'm not aware of. If this, then that, I haven't used this, but from what I understand, it allows you to sort of simply program logical, you check something, and if this state of the internet is true, then do something over here. And PagerDuty, if you're actually an operations person, to be able to send polite pages to people when bad things, stuff like this. So I would definitely say, along with this low-level toolkit of being able to solve problems, see if there's something straightforward out here that'll solve a problem for you. All right, so with that, I'm going to pause a moment, and because I've made sure there's lots of time here, because people are going to just hopefully yell at me, because I need to be yelled at for the drunken stumble. But before we go into the drunken stumble, any questions or comments about the prelude, the stage? No, you're ready. You want to see the drunken stumble. You're like, let's do it. We're ready. Stumble? Okay. So, drunken stumble. Let's do it. So I'm going to build an application platform. I can't even conceive of a platform for an application without an application. How do you even think about a platform for an application without something to get your mind around? So I'm going to take my workstation, my laptop right here, and I'm going to install an application on it. So this is Tomcat. This is a Java-based web server, application server. This is an example. It could be anything. It could be Ruby-based, Erlang-based, Python-based, whatever, C, doesn't matter. Whatever it is I need to build for, I'm going to get working. I'm going to install it on my laptop. Next, I'm going to take Nginx, just pick a reverse proxy. I'm going to put it on my laptop. I'm not going to go provision servers. I'm not going to go out to EC2. I'm not even think about EC2. This is drunken stumble. Drunken stumble is about this process, every step, doing the next reflexive, obvious thing. The next obvious thing to me in this case, sort of knowing what my application topology looks like, is to put a reverse proxy here. Knowing that web applications, and if you didn't know this and you're building an application platform, then my question would be, what are you doing? You're building an application, you don't even understand the basics of your application architecture. So these are obvious things for anyone building a web app. You have multiple backends behind a reverse proxy, so I'm going to add multiple Tomcats, all on my laptop. Next. Now that I've got a local facility working and I can play around with it, I can go to the web browser and say, yeah, my application is working. What's the next step? What would be the next obvious step? Well, The next obvious step for me would be, let's see what happens if we can get this stuff out into infrastructure. So I'm going to start to shift away from cobbling together pieces and start to script things. So I'm going to just automate. I'm going to say, what can I control using scripts? In this case, we're going to pick EC2 because it's easy, right? EC2 provides, I could just try this for a few hours and pay pennies to experiment. So that's completely no-brainer in this scenario. It's the next obvious thing. So you can pick up command line tools to go ahead and create EC2 instances. Very simple. Install them, play with it, try it. Oh, I've got an EC2 instance. Let's create multiple. Now I have infrastructure. Right? The next obvious step, I'm going to add a couple more servers. You're getting bored with this because it's like this is so obvious and simple, but I didn't start out this way. When I started working on CloudBees, I literally said, we need a message bus. AMQP, that's the logical one. I need a rules engine, so I had Java Jesper. Fantastic product. It's complex event processing, right? We need something to go map, all right? If I had done this, we would have been done so much faster, with so much better, with so much less hassle. So even though this seems totally drop-dead simple, in a lot of scenarios, we don't do this. We go and forecast and try to put in large, speculative solutions to problems that we don't have or don't have yet or don't fully understand. So let's continue. Now that I have these EC2 instances, I'm going to push Tomcat to each one of these. I'm just going to do something stupid, like I'm going to SCP the bytes from this thing up to here over SSH, and here they are. Now I've just done this 3 times. I put it into a little loop. I've hard-coded the addresses. I'm just getting it to work. I'm doing the next obvious thing. I have Nginx out here. Maybe I get fancy. I'm going to start to muck around with a database because I know my application needs a database. So I keep incrementally adding this stuff. So these protocols, this isn't, I don't have anything filled in here. What's the protocol? The obvious protocol is SSH. Why would you start with anything else? Why would you speculate? Just get it to work. Use SSH. If SSH becomes a problem, it's not a problem now. If it becomes a problem, then that becomes the next obvious thing to solve, right? But let's not even think about that right now. Don't even let it enter your mind. Continue. Now the problem becomes, well, this is a bit of a bottleneck here, right? Because I'm having to push these bytes 3 times. So I'm thinking about that saying, this feels like the next obvious problem to me. But maybe it's a different problem for you. But for me, it would be, I don't like the fact that I'm having to push all this stuff out here. So I'm going to do a really simple thing here. I'm going to go to S3, an Amazon service, like the same facility here, same virtual infrastructure. I'm going to push my bytes over here. And then I'm going to change my script to these guys to say pull from this. I've just built a distributed application. I'm starting to get fancy here, right? Visionary. It's not. It's the next obvious thing to do because this was a pain point. These are big bottlenecks. This is like expensive I/O coming off of this machine. If I were to do 30 of these, it would be a problem. Even now, it's a problem with 3, so I know it's something to fix. Okay. Next thing, get a sip of water. Let me go back. So I'm sitting here with my workstation. This is literally my laptop. I didn't go and procure a workstation. I'm just doing this with what I have. I think, okay, now I have this working, but it's not usable for anyone else. I'm happy with it. I can deploy applications to the cloud. But the whole point of this is to be a platform. How do I make it a platform? Well, what I could do is I could repurpose the same exact code that I wrote, the scripts. I'm not going to rewrite them in Ruby or Python or Erlang or anything. I'm going to literally copy them from my workstation to another EC2 instance, and I'm going to wrap it hackishly behind a REST API because I know that REST is the most obvious interface without thinking about it. REST is the most, now maybe REST isn't the most obvious for your case. Okay, so you have a discussion. What is the most obvious thing? If you don't know what is obvious, go ask, get more people into the conversation, or go ask your developer community, how would you like to interface with this? Do you want to use Corba? Or do you want to use ZeroMQ? In this case, I've decided to use an HTTP REST API. So now I have a service. I went from my workstation here, which is completely idiotic, to hacking it, to this like cloud. Now I have a service. Really. I can put authentication here if I want to. I can make this as fancy as I want, but behind the scenes are these proven working scripts that I was writing stupidly on my laptop. Okay, with that, now I need to expose this to my end users. So what do? Well, this is CLI, command line interface. Well, curl works really well with HTTP. All right? If you have a nice, simple REST interface, you can have a nice, simple curl-based interface. I wrote these scripts. They're probably command line tools. So heck, I'm a bash expert by now. I can do command line stuff. I know how to use genapp and argument, parsing and that, printing messages and help and man files, whatever. I just did that. Now I'm going to take my skill set and apply it to a command line interface that wraps curl. I'm not going to go use some crazy library. I'm just going to get it to work. Curl works. Now, maybe you didn't know that curl works, and you're somebody who's using Ruby. And there's a Ruby library for making simple REST APIs. Then use that. That's the next obvious thing. Well, you don't even think about it. Just do it. And if you have no idea, and this is your favorite language, Google REST client for Erlang. You'll see that there is none. There's no such. Erlang doesn't have cool tools like that. We have to use this HTTPC client and other things. So I just exec to curl. Anyway, what's obvious to me is maybe not obvious to you, but the point is you only ever do what's totally apparent. And if there's a problem or an issue with knowing what's apparent, then you spend your work elaborating that. Yeah.
So you create this REST API on it, so it's by SSH?
Well, so in this scenario, and this is the scenario I'm making up as I go, it's because, at least I think, my team wants to access this without it using SSH. I just made that up. But that's a good point. And when you're collaborating with people, that's exactly what the question should be asked. Wait a second, Mr. Fancy Pants, why are you even using REST? Why not just continue to distribute this over SSH? That's a great question. Maybe that's the right answer. So what's the obvious thing? Maybe I'm wrong. It isn't clearly the thing to do. And that's the type of design discussion that's great to have, because it doesn't come down to who's the smarter person in the room, or it comes down to intuition. And intuition is based on a lot of different things. Somebody intuitively says, I intuitively said REST. It's Pavlovian. That could be totally wrong, right? But I'm going to spend my time doing that. But look, even if this was the morally wrong thing to do, the universe frowns upon it. Because we're taking these little tiny steps along the way, the consequences of this decision are almost irrelevant. We can back out of that and change it at any point in time because none of this other stuff is affected. It was increment. There was no like, well, we've got this $1 million message bus and it's not working here, and you've just committed to this thing that's going to, like, if you have to change or evolve it, it's going to become very difficult. Something like this, where you're keeping size and autonomy principles in mind, can be more effectively evolved. Okay, so in this case, just go with me on this. It's REST. It's the right thing to do. It's the universe approves. So now I go from my workstation. So I'm just like a developer, Joe developer or Sam developer working in a closet. But then I say, look, it's time for me to start to get my colleagues involved in this. So Joe's workstation gets the same CLI. So now I have a platform. I just created a perfectly usable, effective platform. This is I've built a platform that looks nothing like this. Much more complicated. And of course, things will evolve and it will become more complicated. But if I had just taken this sort of, I'm not going to even design this, I'm just going to do the next obvious thing, we would have gotten there faster, it would have worked better, I would have had fewer painful lessons to learn. But of course, this is the lesson, right? Sometimes we have to unlearn our clever thinking. It's that 1% inspiration, 99% perspiration principle, I think. What do you think? Does it stick? Who knows? All right, next step. So this is my final iteration on this thing. So after Joe and Jane and some other folks are using this thing, like, I got a bug, or my CPU was spiking on this application the other day, and I never knew about it. That kind of bothers me because that's bad for my app. Wouldn't it be nice if we could monitor that? Like, oh yeah, that's a good idea. So why don't we do this? Let's start another EC2 instance, because we're good at that. We know what that is. Let's put some sort of really simple collector here. We're not going to worry so much. Maybe this is going to be HTTP and JSON. Let's just get it to work. Let's make it simple. You can SSH. I don't know if you do that here, right? But let's just get some data streaming over here into a MySQL database. If you are a Postgres person, use Postgres. That is the obvious database for you to use. I might even be tempted to use SQLite. I want to see, hey, what can we get away with? How little work can I possibly do here to get this thing to work? So now all of a sudden we're collecting things, and we have we haven't installed a BI engine, a business intelligence engine, or analytics. This isn't a data warehouse. This doesn't cost $50,000 or $150,000. This is insanely stupid. But next time that CPU spikes, a little report is generated, and we used Pingdom, that service I was talking about, to check the report to see if there was a string in the report that said, CPU error, and then the guy gets a text message, right? It costs nothing and almost no effort at all to get this to work. Now, in time, you'll run into scalability problems. In time, you will have more features. In time, but every single one of those changes will be driven by real pain that will inform your next obvious thing to do. You may have a lot of pain, but it's not the next obvious thing to do. There may be more pain. Maybe this thing is the wrong vehicle for pushing the bytes through. Maybe there's some other feature that you want to add. Right? The next obvious thing is not always the most painful thing. That's it. That's the mystery. It's this guy, this person who's really, frankly, hilarious. If we can own this identity as engineers and programmers, I know this is controversial, but I think we will dramatically improve engineering. I think we'll dramatically improve results. It is remarkable what a total drunk can accomplish physically just by obeying the laws of physics, and the laws of physics will always prevail. So let's just work with the laws of physics and be very iterative and small and independent and only solve the next obvious problem. So with that, I've got a good chunk of time for questions, which is what I want. Oh, wait. Oh, I didn't compile my changes here. It's like having a joke and then failing on the joke and then trying to explain it afterwards. So I'm not even going to do that, but I had a really good ending to this thing. And I'm not going to compile it and show you. But anyway, this is it. This is the end of the experiment. The reason that this is short, and I don't have a lot of how to do this, is because your problem is going to be unique to your solution. There's no possible way I could say, this is what to do. That whole opening gambit about message bus and distributed database and rules engines was absurd. Yet that's how software is bought. That's how it's sold. That's how people start projects. It's that gambit, right? But it is truly absurd because you just don't know what your problem is until you know what your problem is. And then at that point, things become obvious. When you speculate on large, theoretical solutions to problems you don't really understand, you're spinning wheels, you're building bridges to islands that have no people living in them, and it's just embarrassing. So whenever you can implement Drunken Stumble, call it something else. Call it reflex-driven development. Call it Olympiad, whatever. I like Drunken Stumble because, hey, man, I don't own it. So with that, are there any questions and tirades? And yeah.
Say that you have this very complicated system and you have all these complex components and you're really drowning in it. So what are your thoughts on going the other way and simplifying that to what you would feel if you had done it like this?
So if you have a complicated system, how? Oh, if you start, if you. Okay, so let's go back. Yeah. I'm going to do this really arrogant life coach thing. Let's go back to the principles. Treat the problem definition again. Is that really a problem? Do you really need to take this complex thing and make it better? It already exists. But that's an abstract problem. Maybe there's a specific thing that's been hard to change that's the most obvious. So this is the next thing is, what is most obviously the next thing to do? You can't just wave a wand and say simplify it. It's impossible. You're violating the laws of physics at that point. So pick an example of something that's in there. Maybe it's a particular application that has a high throughput that's saturating a particular pipe. That's the logical candidate to move off into its own thing. That might be the most obvious. Maybe it's just a brainstorming. The next obvious thing to do is get together in a room and figure out what the next obvious step is and just hammer it out. And if you can get some level of consensus, then it becomes very clear. But the point is that you're moving forward with these incremental decisions because the reality is you do that anyway. This is just a respect for the process. So you embody that process. You're not like, oh, I know what to do. We've got to go, I, a long time ago, made the decision to phase out AMQP with 0MQ. That's nowhere near completed because there's no reason to. We have things that work perfectly fine. I'm not going to go rip it out on principle. It's not a problem. So it was a non-answer to your question. I apologize.
Yeah. I think Drunken Stumble, that's what I do, but you've got to know where you're going. In the far off distance.
That's the lean. That's the lean. So I didn't formally.
How do I know where I'm going to go?
So I didn't want this to be a methodology talk on Drunken Stumble. That is a very important part of Drunken Stumble because when you are Drunken Stumble, when you're in the dead of winter and need to get home, I know where I want to go. It's that away. That's the lean. So that is called, in the methodology, it's called the lean. You lean, that's where I want to go, And sometimes you end up over here, but you know you want to go, and then,
You've been home many times.
what's that? Well,
Been home many times. You know where home is. So it doesn't really matter where you start. You're always going to stumble towards home.
well, but you always have some hunch. Well, going back to this, you have a hunch of what you want to do, but you treat it as a guess. Like when you guys were doing Erlang, I was talking to Robert after. He said, we never set out to build Erlang. This was never a goal of ours. Right, so what happened? Erlang popped out, but you never had that. Somehow it happened. Yeah. Peter? Is it possible that the market? Oh. Oh, absolutely. No, I mean, it could talk to this, say, well, to an investor, this is what we're going to do. We're using this new methodology from the guy who did MongoDB as web scale. It's called Drunken Stumble. They're like, you want $1 million? Can you at least tell us what you're going to build? No, it's just too speculative. We don't know. Yeah, so obviously you need to be as clear as possible. But I mean, even you look at the way, now I'm not an expert in VC and how to fund companies, but one of the things I've heard over and over, and I've observed, is that venture capitalists will invest in a team. They don't invest in a business plan, because they know the business plan is going to change. So that's an example of a market speculation that wise investors will say, that's just a guess. What we're really investing is in the process behind delivering something of value. We know that this team can accomplish something of value. We don't necessarily know what it's going to be, but the market opportunity is a guess. But it absolutely informs the lean.
I've seen several companies that they're stumbling in that direction, and they do something to solve the problem in that direction. Turns out to be something useful.
Yeah.
They make a 90-degree turn and then make a 45.
What's the percentage? That percentage has to be near 100%. I mean, how many companies actually got, I mean, look at any case study. It's like they started in one area and something popped out of that.
But that's only when they're small. It doesn't work when they're big.
Yeah. Well, that's, so I'm shooting my mouth off here. Give me a few years, maybe I'll be an expert in this stuff. But this is for me an easy way. The premise here is that we want to be skeptical of our brains. We want to respect Thomas Edison's principle of inspiration and perspiration. It's literally, I mean, there's a guy who's like, we need to go solve the light bulb problem, and then they just hammered experiment. Now that's a relatively focused problem, but the point is that we don't really know, our brains, our ideas, our vision is going to get us pointed in a particular direction. The rest of it is rolling up our sleeves and stumbling. I only have 8 minutes left. More questions. Come on, more questions. I want to be like a life coach here. I fancy myself as like this guru, this drunken stumble guru who's like, lean, stumble. Yeah.
Is drunken stumble web scale?
That is an excellent question. Is drunken stumble web scale? Yeah. I mean, I guess by definition. It's so the underlying. So I say I'm not sure. I say I don't know, but I sort of anecdotally do know, because everyone here exists through drunken stumble, right? The laws of physics were applied over time, and we somehow were selected out of a incalculable number of variations, right? Every step along the way was so minute we almost can't even measure it. And along the way, this fantastic process of selection occurred, and we're here in this room talking about getting home in the dead of winter when you can't walk, right? That somehow physics created these incredibly complex interactions in organisms. I know that, I'm pretty sure that this works. I'm pretty sure it works just by the fact that we exist. It's really too philosophical for programming discussion. I apologize, but yeah.
Another philosophical I think this really works to improve the system and get even better. It's like, as a metaphor, you're climbing up a hill, and you want to go on top, and then you stumble to the top. But isn't it sometimes that there's another hill 2 kilometers away which is higher, and you would have started in sort of more preparation, you would have started walking up the other hill. So it's not optimizing, you find local optimization, but it might not be the best thing, and sometimes you have to combine it with something like foresight and more preparation.
So, so in my own thinking, one of the biggest challenges, and so your example is of traversing mountains. I would look at any big engineering exercise like a bridge or a dam or building a super tanker, or how on earth do you get from like drunken stumble to a super tanker? Well, you go to South Korea and ask people who've been doing it for like the last 50 years, expertly, what's the obvious thing to do here, right? I don't know how to build a super. I don't know the slightest idea how to build a dam. I know it keeps back water. I don't have the foggiest idea. What is the first obvious thing to do? I'm going to talk to a dam expert, somebody who's been doing this for a long time. And so then it becomes, part of this is really who's in the room and what's obvious and what's, sort of intuitive. And these bridges have been built, over and over and over again. So it's not like we're going to reinvent that. But in software, we're doing new things from the first time in the history of the universe. So it's difficult to apply traditional physical engineering principles to software, because software is more like organic evolution, because we're always doing something new, and we're never sure exactly why we're doing it. It's speculative. So I think, in one hand, absolutely, you have to, if you're that guy who's traversing the mountains, you're the mountaineer, you do what's obvious. You're like, no, don't look there. I've done that before. It doesn't work. Or I was taught by my teacher, don't do that. I've been trained to do this. Right? So expertise and experience and intuition are central to this whole thing.
Has anything ever gone wrong by you stumbling around?
Are you kidding? Think about it. Has anything gone, you're like this in the trees and you're passed out, you're like, oh, that didn't work. But what do you do? Because it's incremental. So you get up, you kind of dust yourself off, and you're like, okay, let's resume. So by almost like it's part of the thing. But the point is that because everything is so incremental and evolutionary, any one mistake is not going to tank. It shouldn't. Hopefully, maybe it does. Maybe it does. Maybe the problem you're solving is unavoidably risky, and you take a big risk. But then the problem becomes, how do we get back to stumbling? If it's at all possible within our problem set, how do we make our things small, autonomous, incremental? Maybe it isn't possible, and you have a really hard problem. Yeah. You maybe go extinct. I mean, I guess the evolutionary analog to that is extinction. And that happens. Maybe it's inevitable. That's a really good question. Maybe Peter can answer it. Yeah, please. Yeah.
Sorry, changes are delivered very rapidly and tested. And if they're not accurate, they're taken out really quickly. So there's never more than a small number of changes on the fly being pushed through to maturity. Never large amounts of change.
Yeah. Of course, Joe would say you fail fast, and you don't hide state that is bad. You crash immediately, make it visible. So these are principles that you say, what happens if we don't know? Well, let's know. If it's that important, and maybe you do this a few times, and you make that series of decisions that are linked, and you get intractable. Everyone does that. I mean, how many people have written code bases that are intractably horrible, and you just want to throw it away? That's extinction. Just throw it away. That's reality. Don't be afraid of that. But then you get experience, and then so it's just what you do. It's just like it's part of the process. It's a messy process. There's nothing clean or elegant about it. It's drunk and stumble. That's why it's drunk and stumble. It's not the Olympiad at all, in reality. Okay, so I have a couple minutes. So there's any other, maybe one or two questions. Yeah.
Okay, this will be one more last question, please.
Sorry, I kind of like this idea, but isn't there? If it is a drunk and stumble around, it's just random, then
Yeah, go ahead.
Isn't there some sense in which working software is a coincidence? The sort of hundreds of monkeys.
No. This gets back to the lean. I know I need to get home. It's not I don't know why I'm here. It's I absolutely have an objection. It is to not die in the snow. It's unequivocal and it's very, very clear. But then the question is, how do I do it? And so, yeah, if you don't have a lean or some idea of what you just need to be skeptical of it. Just don't be like so arrogant and confident, not to say you're at it, but like people are like, this is what we've got to do, and they presume to know exactly what they're doing. Just be skeptical of it and say, this is a guess, and then reevaluate it at every point. So the lean gets reevaluated. Maybe you took the wrong step over here, you stop and say, oh my, I live over here, and then you stumble that way. So it's really elegant methodology, isn't it? Okay, thank you very much. Appreciate it.
Thank you.